My name is Drew Griffiths, and this is my presentation on Physics 2211 Lab 4 Oscillations. So the purpose of this lab is to compare the observed motion versus the predicted motion of a spring mass system to determine if the model follows the energy principle. And I use the tracker software to track the data of the experiment and the ClosScript code to model the data and then compare them. The result was that the total energy of the system remained at 0 for the model, so it satisfies the energy principle. And here are the fundamental physical principles that I used during the lab, the velocity and position update formulas from previous labs, and then kinetic energy equals 1/2 mv squared. The gravitational potential energy equals mgh when the system is close to the surface of the Earth, which it is in this case. The spring energy is equal to 1/2 the spring constant times the stretch squared, and the total change in energy is equal to the work of the surroundings plus the thermal energy. And the energy principle states that the change in energy equals the kinetic energy plus the gravitational potential energy and the potential spring energy, which should equal 0 if the energy principle is satisfied in this lab. And here is my tracker software. So you can see here on the left, this is the experiment. The spring mass system is oscillating in a arcing motion, causing the position in the x and y direction to be kind of like a sinusoidal curve. And here is my ClosScript code. So as you can see here on the left, this is mostly the initial conditions, but using the ball mass equals 0.402 kilograms, the position being 0.106 and then negative 0.634 meters. And then the initial velocity is 0 because the spring mass system is dropped from rest. And then also over here on the left, these 4 lines used to compute the system energies are the equations for each type of energy that I showed earlier. And then again, you add them all up to get the total energy. Then here on the right is my while loop. And I calculated the force of gravity and the force of spring and add them together to get the net force. And then once we have the net force, we can put that into the velocity and position update formulas to then calculate the velocity and position and track them. And then again here's the equations for the energies and their deltas, so the change in each energy. And the total energy should add up to 0, which is E minus the E initial. Okay, and then here are my results for the positions. So obviously, as you can see on the graphs, the positions aren't exactly the same, but the model was successful in making the position being a sinusoidal curve. Some errors that could account for the differences in position between the model and the experiment are possible influences from the surroundings, because in the model there was no surroundings, but obviously in the experiment there's surroundings acting on it, and in this model the system is only the spring, the gravity, and the Earth, and there's other forces acting on the experiment. And also there is possible potential inaccuracy from me placing the center of mass in the tracker, which slightly alter the experimental positions. And then here's my graph for the change in energies versus time. And the energy principle is satisfied since there are no outside sources acting on the system. As from earlier, the change in energy equals the work of surroundings plus the change in thermal energy, the transfer of thermal energy, and since there's no surroundings, no energy is transferred, so the change in energy is still 0, as you can see here by the yellow line on the graph. So the potential energy of the gravity plus potential energy of the spring plus kinetic energy will all add up to 0 because the energy is conserved. So then what do the oscillations period mean? So I calculated the oscillation position, the oscillation time in the x direction to be 1.623 seconds, which I calculated by averaging 3 oscillations together to find like the average oscillation. And then I did the same thing for the y direction. And the difference in the directions of the oscillations would cause a difference in the periods. and ultimately it would change the graphs and my position data.